Okay, hello. I think we can start now. My name is Anastasios Daskalopoulos. I have been working for the company Exo since February of this year. This is my first, initiation into the world of Drupal. I do have content management experience because it's been approaching 10 years now. I was the test manager for Nokia.com for a few years, where Nokia.com basically used its own bespoke, its own created content management software. But a lot has changed since then. To tell a little bit more about my own experience, I've been working in software testing for the past 15 years. And I got into it accidentally, and I actually ended up here accidentally, where I ended up applying at Nokia for a software testing job. And much to my surprise and complete shock, I got it. And that marks, actually today, August 26th, marks exactly 15 years of me here in Finland doing software testing. So yes, it's an anniversary we've come upon. And I've been doing software testing in numerous projects for the first almost 10 years at Nokia in many different facets at Nokia. But we all know what happened to Nokia, unfortunately. So I've had to branch out my software testing experience and my software testing ability. So fortunately, I'm back into content management and software quality in content management, and that's what we'll talk about today. We'll be talking at a higher level. We're not really going to talk about actual bug finding or bug testing or any kind of real hands-on testing, but we're going to talk at a higher level about what software quality is. What does it mean? How do we find it? How do we look for it? And how do we know if we even got it? So let's start. And also, before we go on, I would like to turn these kinds of presentations into conversations. So if you have anything to say, if you have any questions, disagreements, agreements, any kind of comment, well, let's talk about it, okay? And moving on, I asked, what do we mean by software quality? Okay, that's a question we're going to try to answer today, or at least try to get a better idea. I've been able to find numerous ideas of what quality is, and I'm going to throw one out just right now. Software that functions according to the requirements of the developers and to the needs of the intended users. Okay? That's sort of a mid-sized, sort of a compromise idea of what software quality is. Going a little bit deeper into this, we can ask, what is a bug? The funny thing is there is no real definition of what a bug is. Probably the closest, maybe the easiest definition is any unexpected or undesired software behavior. So anything you don't expect, we'll call it a bug. But we'll go more into that a little later. But let's talk about definitions now. Software, as it says here, is functions according to the needs of both the developers and the end users. Just in my experience and in my philosophy of bug finding is, as a tester, I've always wanted to represent the end user. Representing the developer, yes, is important. Representing the requirements writers, the stakeholders, the very big level people, is also very important. But in the end, it's like the actual person at home who's clicking around in the website is the one that I've always found very important, the most important. But why doesn't software work? I remember in my last company, the production manager would, after the build was finished, he would always ask me, okay, here's the build, now try and break it. He'd always urge me to try and break the software. I didn't really have the guts, so maybe I should have said this, but I was never actually able to tell them that I really have never had to try and break software. You know, it's always been just kind of broken in it by itself. I don't have to try and break it. It's my job to find out where it is broken, but trying to break it is beyond what normally happens. Sometimes that does happen, but generally that's not the case. I don't have to try and break it. But what do we contribute this? Is it developers' carelessness? Is it poor management? Do things just go wrong in software development? Is it like a car that breaks down? Does software eventually break down just like a car would break down? Or is some software just, I guess you can say, lemony? You know, so it's like maybe you get that bad car that comes off the assembly line. Can software be like that? Why do things go wrong? And is there anything we can do to keep things from going wrong? Is there anything we can do to make sure that software functions in the way that we, meaning all of us involved in the development process, and the end user who actually employs the software? What can we do to make things function better? And also, I should talk about like the history of software testing. As a job, as a profession, this is a very new field because the first software guidelines, the first software testing book came out in 1985. Maybe the whole idea of software isn't that much older than that, but ever since the idea of software tester really came in the mid to late 80s, really in the mid to late 90s, when you really come down to it. But things have changed a lot. Like I originally started as a Java developer a long time ago. And like I said, on a lark, I applied for this company in Finland and ended up getting the job and ended up getting here. And just for me personally, I personally have found software testing to just be more interesting than actual development for a number of reasons. But things have changed a lot. At Nokia, when I first started working there on the S90 system, the S90 operating system, things were very different. And things are changing for the better. But back then, there was basically a room full of testers who actually like went down a checklist and said, you know, push this button, then you cross, okay. Then you go to the next step. You had to really enjoy checklists a lot to be able to do the job. And if there was a bug, the people who actually fixed the bug, you would report the bug to the Nokia office, ironically in San Diego, in California. So not only were the testers and the developers not even in the same room, they weren't even on the same continent. The developers were in San Diego, and they would eventually fix the bug and you would get it in. So it was a big, huge, long process. I remember one time we had to wait a month just for an operating build to be made. The builds wouldn't even pass the smoke test. So it was a long process, and the way things in software development have gone faster and faster, there's just no time to really wait literally a month for a working build. And also, budgets being what they are, there's no opportunity to pay literally like a room full of like 30 people to manually go through the software manually, just one step at a time as it used to be done. But things are changing, and the whole idea behind this is to fit the testing into the agile framework, into the agile environment itself. Okay, so the point of what we do is find bugs. You know, how should the software work? And just to let you know, I'll be starting with software at a general level, and I'll be kind of filtering down to Drupal. As we go on, I will be talking about Drupal specifically. But to just kind of sit back and talk about bugs. I first want to talk about the whole idea of what is a bug. Like even starting off from the very concept of the word bug. Does anyone know where we got the word bug? Yeah, kind of. There is an idea of like in 1946 in one of those big mechanical computers that I don't think would even fit in this room. You know, back when a computer was this big, huge mechanical thing. In Washington, D.C., I think it may have even been for the U.S. Navy at the time, one of these big mechanical loud computers just stopped working. And they had to take it apart, literally unscrew the computer and kind of use wrenches and screwdrivers to unravel it, to take it literally physically apart. And apparently somebody found a moth, literally a bug, stuck inside one of the mechanical switches. So that literally is a bug in the computer. It was stuck inside and blocked one of the switches. And ironically enough, they kept it. You can see it today at the Smithsonian Institution in one of the exhibits, that the moth itself is under tape. You can actually go and see the bug itself. Yeah, that's sort of a folk etymology. That's actually a true story, but the word actually goes back a little farther than that. The inventor Thomas Edison in 1878, I think I got this quote. It's worth looking at. It's worth going through because even though it's in 1878, it still has to do with what we go through today. Yeah, Edison said, "It has been just so in all of my inventions." Remember, this is the guy who invented the light bulb, the phonograph record, in other words, recording sound, the moving picture machine, like film, and numerous other things. Ironically enough, have you heard the story why he invented the light bulb? Because he didn't believe in sleep. He literally thought electric light would make sleep unnecessary. So he invented the light bulb so we wouldn't have to waste time sleeping. But things didn't go his way all the time. He did end up inventing the light bulb, but in 1878, still fairly early in his career, he said, "It's been just so in all of my inventions. The first step is an intuition, and then comes with a burst, then difficulties arise. This thing gives out, and it is then that bugs, as such little faults and difficulties are called, show themselves." And he says months of intense watching, study, and labor are requisite before commercial success or failure is certainly reached. So Edison used the word bug in the same sense we do. He had to deal with bugs in 1878, as we have to do now. And he really calls them the little faults that take a long time to get rid of. And that's one thing we have to keep in mind, little faults that take a long time to get rid of. But I started exploring a little more. Like, is there anything else about the word bug, the concept bug, that can help us? Out of curiosity, and interestingly enough, in my opinion, like the word bug is of unknown etymology. What does the word bug mean literally? We don't know. But there are a few words like that. just keep in mind what we did earlier today, like the word lunch is of unknown etymology. The word job, etymology unknown. In fact, the word pizza, it's like, and what does pizza mean? We don't know. But even more so, the word bug, etymology unknown, it probably goes back to an old Celtic word meaning threat, like any unknown threat is a bug, originally, going way back. And that's how we ought to see the word bug as we mean it, as a threat, an unknown threat. And that's how we should regard them. Not just little problems, but threats to the sales of the software itself, instead of just something you have to clear up before anything we do can be released. And speaking of releases, I like to show some of these examples. What I like to call famous software disasters. Where have things gone really, really wrong with software? And this goes way back, nothing new. Remember, these aren't mechanical problems, these are all software problems. If you can think of a good example yourselves that you've come across, let me know. We'll talk about more of these. But going back to 1962, Mariner 1 had to be blown up manually after 5 minutes when it started veering off course. And also, since I basically started, I'll be doing a lot of aerospace examples here, because that's where I basically started with technology, with airplanes. Actually testing and working with airplanes and airplane software. Because as you can tell, as you would imagine, you don't want, the airplane is a very electronic thing. It has a lot of software in it, and a lot of it unfortunately doesn't work. I don't mean to freak you out, but a lot of it doesn't work. Especially when they're trying it out, like the example, like not even last year, a year ago or so, I can't remember exactly when, but the Airbus A400 military transport plane crashed in Spain because of a problem with the software. Literally, the software kept the engines, the EQ, as they call it, they kept the engines running on takeoff, so the whole thing the airplane just stalled and crashed. So when you test airplane and avionics software, the results can be really dramatic if something goes wrong. We don't have that problem generally, but here are other problems. This was a funny issue, but the 1998 Mars Climate Orbiter, literally the imperial, the US measurement versus the metric measurement. Lockheed Martin's ground software, as it says, calculated the insertion of thruster firing, the gas in other words, in English-based pound seconds, whereas the NASA software on the orbiter itself was expecting results in the metric system. So what ended up happening is the Mars Climate Orbiter might be on Mars somewhere in pieces, or it might be floating out in the Milky Way somewhere. No one knows where it is. Because one was calculating in the old English system, whereas the machine itself was expecting the metric system. And there goes $327.6 million right there, because of that kind of software error. Again, the Mars Spirit rover was actually on Mars, but a flash memory problem caused the memory to fill up. And even though it was on Mars, all it did for a long time was it just kept rebooting endlessly. Okay? They managed to get it on Mars, it was on Mars, and all it did was reboot for a long time. I think that was fixed. The Mars Global Surveyor. Unfortunately, now a software problem has made it go into safe mode, and Apparently they didn't test this well because you can't contact the Mars Global Surveyor once it's in safety. Things a little down to earth. I've never actually tried this myself, but Excel 2007 always had similar calculations like 850 times 77.1 equals 100,000 regular. And they claim this is fixed. I'll trust it's fixed. Somebody can try it later. But apparently this wasn't a calculation error, but it's something that just displays. It didn't display the full answer, the correct answer, but just wrote 100,000. And some of these things started getting a little funny. I try not to use the actual URL itself, but you could get a free hotel room by simply changing the fee in the URL to 0.00. Oh yes, the Google Maps error. These get kind of Apple Maps. Google Maps had an error too. These are the Apple Maps. If you try these view, you should actually try this out. These get really just psychedelic after a while because the bridge ends up going into the water. Here we've got the river suddenly rising up and then going back down the road. Like I said, it gets very trippy. But this was released. I haven't tried Apple Maps since, but I'd be willing to try it now just to see what happens. There's a Google Maps error. The Arlington National Cemetery was labeled on the maps as a restaurant. Amazon. Again, this was in the late 90s, but you could actually get free books if you just put a negative value in the quantity field. And you'd be given credits instead of having to pay. Okay, we talked about the Airbus A400. And we saw this a few weeks ago on the news that there was a prison software that would calculate prisoners' sentences that would unfortunately release prisoners early. Generally wasn't a big problem. The average release was only 2 months early, but there were some very violent criminals. This is in the state of Washington specifically, where people were released early, violent offenders released early. And something that we caught at Drupal with Drupal it's just a Drupal error. This is still Drupal. This is Drupal 7. I was told this happens in Drupal 8. If you run a command to stop the cron trigger, I think even delete the cron trigger, it'll tell you what happened, but look at the last run. Did you notice the last run? Yeah, it's been a while, hasn't it? Hasn't been run in the past 46 years. This is reproducible even on Drupal 8. And unfortunately it hasn't been fixed yet. And we'll be getting into Drupal errors in a few minutes. Okay, and here we'll talk about what is quality. Different definitions of software quality, and my experience in what software quality should be and what actually happens. The first definition just goes to, and you can agree or disagree. Like I said, I don't know. That's a problem with the word quality. How do we know we have quality? To me, it's the same as talking about like what makes a good movie. Is there a way to know, to prove that you've seen a good movie? Same thing with pizza. Can you prove that you've had a good pizza? Definitions can be kind of lacking, but we have to have some kind of documentation for the customers, for the clients. The first definition we have in this interesting book, Software Quality, The Elusive Target, manufacturing. Software quality is the capability of a software product to conform to requirements. We had in Kalle Lagisvirta's presentation this morning an idea of how the idea of requirements can change. It's very difficult to talk about software quality just in terms of requirements, just in terms of meeting requirements. He showed in his dating software the one-word requirement that just said flirt. That's it, just satisfy flirt. I had a similar thing with telecommunication software where the requirement was just one word that just said slam down. That's it, just one word, slam down. Did we satisfy the requirement in testing? Apparently yes, but that may have been just an accident. I may have just been lucky. My point is that I will argue throughout is that quality is basically everyone's problem. In the end, we do have to conform to requirements, whatever those may turn out to be, but simply conforming to requirements isn't any guarantee of software quality. And unfortunately, I've worked in projects where the developers, the development management said, hey, we did our job in satisfying the requirements. Anything else might happen isn't our problem. And one thing I want to get across is quality is everyone's problem. The job of quality assurance is to stand independently of the development process and to represent both management and end users. So we have to find out where things diverge from the requirements. The requirements themselves, meeting requirements just isn't enough. This is sort of the opposite view, the transcendental view. What I've been talking about, like how do you know you have quality? This is like a transcendental definition. Equality is something towards which we strive as an ideal, but may never implement completely. So we may not have quality, but we don't know. This view is closer to what, in paraphrasing the U.S. Supreme Court Justice David Potter in 1966, said about obscenity and pornography. Can you easily define pornography and obscenity? No. Similar to quality is quality. You have quality when you know it when you see it. And like I say here, there's no way to really define or in essence pigeonhole, like track down and grab the concept of quality. You just know it when you see it. And again, with this definition, it's very difficult to define. Same thing like you're taught and you've experienced and you've been asked the question, does a certain software work? Do we know if it works or not? You have to define work. What do you mean by work? Okay. Other definitions, like here, the context of use. This is basically a lot more definite. Does the software fulfill user needs? The manufacturing is about requirements. This context of use is about customer needs. Does the software fulfill what the customer wants? And you can measure it some way, by are the customers happy? Are there any complaints? If so, how many complaints? Are the complaints going down? And are the sales numbers going up? Okay. Other thing, the last one here. But the last one. We have the idea of product. Okay? Quality can be appreciated by measuring the inherent characteristics of the product. Okay, basically, who cares about if the customers are happy, or is it just good software on the technical sense? The product quality is simply measured by what it says it can do. If the product performs the tasks, then yes, it's a high quality product. The issue I have with this is it may not be the product that people want. It might be high quality, but it may not be what's really needed. It's the concept of verification versus validation, which we'll talk about a little later. I started thinking, when I saw this definition, I started thinking about the car, the Ferrari. Let's say, for example, a Ferrari Italia. Great car. You can measure exactly what makes it a great car. But at the same time, if you need to drive it on the gravel and dirt roads to get to your cabin in the woods to go fishing, it's not what you really want. So in that regard, the Ferrari Italia is a poor quality car. So it depends on use. And the last definition here is the perspective is value-based. This basically means different things to different people. As a developer, we might be very proud, very happy with our software. The management might be happy with the software. However, the customers may be very unhappy with the software. The experience I have with this is that, yes, it might be good software, but if nobody can use it, what's the point? I remember working, I shouldn't say the name of companies, but at a different consultant company, there's I'll just say a large Finnish department store in downtown Helsinki, I'll just put it that way, had a retail software developed. But it was so difficult to use and complex, the store workers themselves couldn't use it. They actually couldn't figure out how it worked. The other consulting company, which again I shouldn't use names, said, yeah, it works. It's not our problem if you don't know what you're doing. That was literally their excuse. It's not our fault if they don't know what they're doing. And again, bad definition, bad idea, bad attitude. It's your job to make, in my opinion, it's the development's job to get people software that they can use. You can't say, well, don't blame me if you can't figure it out. Okay. But going on, these are more definitions of software quality. I do want to talk about a few things like here. One thing we need to get across before we get to the actual Drupal examples is the things we should be striving for in developing. The idea of reliability. An attribute of resilience, structural solidity, reliability measures the level of risk and the likelihood of potential application failures. The idea of failure is very loose here. Basically, in software testing, we're looking for two things. We're looking for software bugs. We're actually looking for software errors. And we also look for what we call user expectation bugs. Things that look funny. There may not be a strict definition of a software error, but there's just something wrong. Going a little more, efficiency. The source code and software architecture attributes are elements that ensure high performance once the application is in runtime mode. Okay, so we need efficient software. Security. Yeah, this is something we're paying a lot more attention to now, because if the software, if the application isn't secure, then again, that's a measure of poor quality. There has to be a degree of maintainability and size. And this is what we look at. This is one of my main issues here. Let me know if you agree or disagree, but ultimately, the voice of the customer is important. Software development is all about satisfying the needs of the end user. You're not developing a website really just for your own use. You're employing it for somebody else's use, and you have to make that the important thing. And to this end, like Kala mentioned earlier, we have to find out what they want in order to fulfill one part of the software quality, known as verification and validation. Validation means you have to ask, are you building the right system? And verification means, are you building the system right? Okay? Talking about that a little more. Verification, validation, system right versus right system. And as we say, the definition of validating the software is by proving conclusively that we are building the right system. Is this what the customer wants? Is this what management wants? Is this what the stakeholders want? Versus verification basically means, does it work? Is it working correctly? Is it buggy? Is it not buggy? Okay? Just think, when you're developing, are we building the right system? And is the system right? Okay, going on quickly. This is what we're looking at today in software testing. Basically, the whole idea of a big room full of 30 people all going down the checklist basically isn't done anymore. That actually stopped like I think it was 2 months ago that, did any of you hear this? Yahoo basically fired all of its software testers. That's a bit of an exaggeration, but they basically stopped having a room full of people testing the software and going into basically this agile-based idea of testing. And what we try to do, and the whole idea of agile testing is that there isn't what we used to call like over-the-wall testing. In other words, a piece of software isn't developed and then you throw it over the wall to test it. What we like to do now is to have people like developers and software testers, or even just a tester, a QA person, call it whatever you want, basically working in parallel. Development and testing happens at the same time. Here you don't have to worry about, okay, we're done developing, now we have to just wait for testing to be done. We're not really doing that. It happens in parallel, and it happens as the work goes on. Okay? And last thing, one of the last things, all bugs have to be fixed. Okay? An idea is there's no such thing as a minor bug. All bugs have, as I hear, a deleterious effect on the end user. Literally means poisonous. Bugs are poison. Bugs are venomous. They hurt. They may not really have an adverse effect on the software, but they'll have an adverse effect on the customer. Okay, so fix everything. Because if you don't, you get to the problem of incremental degradation. Okay, defined as the result of tiny progressive reductions in the quality of a product or service over time. If you leave one little bug in, you'll just leave this other little bug, and then another one, and another one, and then they start to multiply, and the big effect is disaster. A big example of this is the 1986 Challenger disaster, the space shuttle, the first space shuttle that blew up. Basically, little errors were left in because it could still fly, and then just more and more and more bugs were left in to the system. Because, if you leave in one, then you can just add one more and one more until you get to disaster. Okay? But let's go to Drupal itself, like actual bugs, Drupal errors, problems that can be fixed or can't. This is actually a YouTube video, and the problem is the user was instructed to press the play button. Do you see the play button anywhere? Can you find the play button? Yeah, it's kind of in the center. But if you're just on a web page, or if you're in a mobile device, even worse, you'll never know that something really cool is supposed to happen when you push the play button. Now I can ask you, is this a bug? And also, what about the text? Like, apparently this is important text. Can you kind of see the text? Maybe here, maybe you kind of see the text? I sent this back. I reported this as a bug. And it was sent back to me saying, yeah, there's nothing we can do about that. And I had to send it back and saying, you got to try and do something about this. Because again, if you're trying to get the user to look at the software, they can't see it. They can't use it if they can't see it. And this is where I talk about fulfilling user expectations. We have to fulfill user expectations. For example, another thing here. Is there anything wrong with this picture? Again, I had to send this back as a bug. Because look at the person in this picture. Apparently, the actual photograph, the insert itself that you actually attach with Drupal into this, has the person's head in the picture. To me, this I reported this as a bug because what if you're this guy? What if you're this sailor? What if you're in this picture? There are other companies that we represent where numerous other bugs are here. Again, I was told, well, that's just what Drupal does. You know, there's nothing we can do about it. And again, I have to report there's got to be something, you know, because people don't want to see this. There are other companies where, you know, there are portraits, thumbnail portraits that only like took the person's chest, you know, or just like 1/4 of their head. You know, and again, that's a problem. That may not be a bug, but that's an expectation error. Other problems that Drupal had trouble solving. I actually got this complaint from the client, where the client said the button is not green enough. And the problem here is, you know, I don't know how to make a button greener, but you have to use your creativity as a developer to solve these kinds of problems. Apparently this was solved when, you know, the developer wanted a darker green color, or just something to make it stand out so the button would be green enough for the client. And here, the client was satisfied. As a developer, yes, the requirement was fulfilled, the stakeholders would have been happy, but the client wasn't happy. Okay, we talk a little bit about test-driven development, the tests being created first, and unit testing. Unit testing needs to be more common, and probably the best way to figure out to encourage unit testing is to budget for it. You know, a developer told me unit testing isn't done more often because they're not really being paid to do unit testing. It's not budgeted. If they're budgeted, it would happen. So I just did summary to finish up. Quality, as I say, is elusive and difficult thing to define, but one that ultimately must satisfy end user expectations and needs. And again, my big point is the job of quality assurance to work beside but independently of development to both validate and verify the software to make sure that Drupal develops the right system so that customers will have a system that works right. Okay, that's all I have. So think about quality whenever at all stages of development, and listen to the testers and see things from their side and from the customer side. Okay, that's all I've got. Thank you.